This is the study of geography, and these are the branches of geography: physical geography, human geography, and practical geography. These are among the few topics that we look at when we study geography. We look at industrialization, we look at forestry, we look at tea plantations, maize plantations, brick making industry, among many others.
Hello, this is your geography teacher, Sarah Nyakundi, and we are looking into geography form 2, lesson 7. We are talking about folding, that is our topic of study, and we are looking into the landforms that result from the process of folding. The previous lesson, we talked about the parts of a fold and the types of folds. And of course, we could ask ourselves, what will make the types of folds look different and the landforms therefore look different? So the rate of folding is determined by the nature of the rocks. The material that is being acted on, the crust of rocks. If these rocks are a little hard, they may not fold as much as the young and the very plastic rocks can fold. And when we talk about the temperature in the rocks, are these rocks very cold or they are being subjected to some volcanic activity and therefore the temperatures inside them are high? If the temperatures are high, that means they have been overheated and therefore they are most likely to be a little soft or plastic, and therefore they can easily be bent than when they have not did not have high temperatures. And then we can also talk about the nature of the forces, the strength of the compressional forces. If the forces are too severe, of course, they will really fold the crust of rocks. If the forces are mild, we are going to have moderate activity being demonstrated or being witnessed, you see. So we are talking about the strength of the forces, the nature of the rocks, and the temperature in the rocks. Of course, the nature of the rocks will include the size of the material that is being involved. If the size is large enough, then we are going to have very high peaks of anticlines. If the material is small in size, of course, we are going to have a very small hill, and we call it an anticline. That is good. So we talk about the landforms, and here we have a part that we call the folding leads to the formation of fold mountains. Fold mountains are actually, now we are talking about the anticlines, exalted anticlines, very large and extensive land that has been folded upwards. And this part here is one of the features when you look at a huge anticline. Now we don't call it an anticline, we call it a fold mountain. Now, then how does folding lead to the formation? What is this process that is involved? Now we talk about the initial process. The first step in the formation of a mountain or a fold mountain is the formation of a depression on the earth surface. And that is what we have here on our screen. That this is the earth surface and we have some part that has been downfolded. This is what we call a depression. Now, when we have a depression on the earth surface, what will happen is that most likely we are going to have water because of the force of gravity being drawn into this geosyncline, into this depression. And this depression, we call it a geosyncline. This depression now, because water is flowing into it from the neighboring mountains and highlands, it will obviously pick some sediments and bring and pour in the depression. So the first step is the formation of a depression. Then we have rainfall and the surface water. They correct in this depression together with sediments. They make the weight become excess, making the depression to be sunk deeper into the crust or rocks. So we are going to have an extension, an overextended geosyncline. When this geosyncline expands like that, what it means is that it collects more water and more sediments. That is what we are going to witness in our second stage. We have very large depression and very large sediments have been deposited there. So what do? The sediments will exert force on the crust or rocks, causing or triggering the occurrence of compressional forces. So when the compressional forces start working on them, now they will cause this part to sink deeper into the interior of the earth. That is what we are going to see. And now, when it has been sunk much deeper, it means that more materials were collected and the compressional forces became more severe, and they compressed this geosyncline to form upfolds and downfolds, what we call the fold mountains and the depressions there, the anticlines and the synclines. So that is it. So that is how a fold mountain was formed. A geosyncline or a depression was present. Water flowed there with some sediments. Then the depression became bigger because of the weight of the water and the sediments. Then the excess weight triggered the compressional forces, which resulted in the over deepening of the geosyncline, even to cause more materials now to be drawn into that geosyncline. And as these forces worked on this material, they led to the formation of our fold mountains. That is one. And then we have the other part, the other landform of of folding is the intermountain plateau. An intermountain plateau is a flat land that exists between two fold mountains. Obviously, when we have a fold mountain here, this is a fold mountain and this is another one. In between is a depression. But sometimes it may not be a depression. We may have the land being just flat. Why? Because the rocks here could have been the old basement rocks which resisted folding. So the rocks here were folded upwards. These ones were also folded upwards. And at the center, in the middle part, the old hard basement rocks resisted the folding. And therefore we have a flat land that exists between two fold mountains. That is what we call an intermountain plateau. That is in between two mountains. Very good. Then we talk about the third landform is the Intermountain Basin. The Intermountain Basin is a depression that is existing between two fold mountains, of course, two anticlines which have been raised too high, and in between them we have a depression there which may collect water, and therefore we call it an intermountain basin. Then from there now we move on to our next subtopic that we call the theories that explain the formation of fold mountains. Is it really true that these fold mountains that we have were formed from folding? So we have theories that have been advanced to try and convince us that fold mountains were formed out of folding or out of any other. So we have about 3 theories, and the first theory that we have is the cooling and contraction theory, the theories that explain the origin of fold mountains on the Earth's surface. We have the cooling and the contraction theory. If we can go back to our first topic in Form 1, that is the solar and the Earth and the solar system. Then we talked about the theories that explain the origin of the solar system. We talked about the passing star theory. This foreign star that came near our sun and it plucked out some materials, and the materials tried to follow the fast moving sun or star, and they could not catch up with that speed. Then these materials, they cooled, they found themselves away from the sun, they started cooling, then they condensed and solidified to form the planets that we have and other heavenly bodies. Now, that theory may be the one that is responsible for the formation of our fold mountains. Some great thinkers, they tell us like that. They say that when the materials that were made up of hot gases and dust found themselves in a cooler environment, the outer materials cooled rather earlier, faster. And we all know that this material, the outer materials, are less dense and lighter than the materials that are in the interior of this of the planets. So the materials from the outer part cooled faster, and as the gases continued cooling into the inside, the outer part now wrinkled, found itself on the outer part, and it wrinkled. It formed ups and downs on the smaller part that is inside, and that is what we call the fold mountains, of course. That is one theory, the cooling and contraction theory. And then we have the second theory, is the plate tectonic theory. We talked about the plate tectonic theory. This is the Earth crust is made up of rigid blocks which are floating on the mantle, and they are either moving towards each other or away from each other. And now these plates, when they move towards each other, or when the simmer material and the continental material, when they come towards each other, then they are forced to fold and form fold mountains, just like the way Africa is being pushed up towards Europe. So we have fold mountains on the part of Africa, the northern part of Africa, and some fold mountains in the southern part of Europe. That is the plate tectonic theory. I don't know whether you support it or you support the earlier theory of the cooling and contraction theory. Then we talk about the confection theory. The confection theory talks about the interior of the earth, where we have the interior of the earth is made up of the core, the mantle, and the crust. The mantle is the middle part, and it's very large and it's very hot. The outer part is the crust, and it is light and it is already solid, cold and solid. Now the mantle is divided into two. We have the upper mantle and the lower mantle. The upper mantle is semi-molten, and therefore the material is constantly in motion. The molten material is in moving in confectional currents. So these confectional currents, they move from the lower part upwards towards the crust. That is vertical movement. When they reach at the base of the crust or rocks, what they do, they are forced to move horizontally, and making the lower part of the crust to be the roof of the confectional currents. And so when these materials are moving, they are semi-molten. We have gases and solid particles and liquid. When they are moving forward, they cause a dragging effect. And remember, the crust is made up of very light materials. That's like aluminium. Now, then the confectional currents, as they are constantly in contact with the crust, they become cold and heavy. They start moving downwards into the interior of the earth. At the point where they are going to move down into the interior of the earth, they cause severe dragging effect, which makes the surface, the crustal material, to make ups and downs, upfolds and downfolds. Those are the anticlines and the synclines, which we call the fold mountains. So we have three theories. We have the cooling and contraction theory, the plate tectonic theory, and the confection theory. Those are the three theories that we have. And therefore, these theories, we shall look at the distribution of the world fold mountains. Let us have a diagram here. This is our Earth surface, and we have our Africa, which is our land. So we have some fold mountains down here in South Africa, which we call the Cape Ranges. At the North Africa, we have the Atlas Mountains. In Europe, southern part of Europe, we have the Alps. In Asia, we have the Himalayas, where we are going to have Mount Everest. Then we go to South America, where we have the Andes. And we have in North America and Canada, on the western part of the continent, we have the Rockies, and on the eastern part of North America, we have the Appalachian Mountains. All those ones are fold mountains, and they were either formed out of the cooling and contraction theory, out of the plate tectonic theory, or out of the confectional theory. I don't know which one you support. But the reality is that we have those fold mountains on the Earth's surface. And that brings us to the end of our lesson. And I want to say thank you, and you are welcome to the next lesson.
Continue watching this YouTube channel, where you will get more similar content to help you during your study in high school. And kindly share so that your friends can get the same kind of content and be helped in their study as well. Thank you. Have a nice time.